Okay, so if you look at this polynomial, y equals x to the fourth minus 3x cubed plus 5x. Okay? And I went ahead and graphed it on Desmos here for you. Let's talk about some things we already know. How many zeros will it have total? 4, because that's the highest degree, that's the highest power, right? Okay. But now looking at the graph, I can tell you that 2 of the zeros are what type of numbers, and then the other 2 must have to be what type of numbers? 2 imaginary and 2 real. Okay? I can tell that because I can see the 2 real ones. They're right there and right there. Those are 2 real numbers, whatever they are. I'll click on them here in a moment to show you what they actually are, approximated. But those, I only see 2 real zeros. So the other 2 must be imaginary numbers. You will not see those on a graph because the x-axis does not have imaginary or complex numbers on it. Okay? The x-axis is made up entirely of real numbers. So we know that the 2 real zeros are right here. The other 2 must be imaginary. Okay? If you wanted to find all 4 of them, okay, what you would have to do is you'd have to do synthetic division with that 0, do synthetic division with that 0, and then you'd be down to a quadratic, and then you could do the quadratic formula to find the 2 remaining imaginary zeros. Okay, which is essentially what we did last test. All right, but here I'm just more concerned about the graphs of them. All right, how many turns does this graph have?
3.
3. 1 less power than the highest power, right? So there are 3 turns. Okay? So we know the number of terms, we know what zeros are, okay? The thing that we have not talked about yet are maximums and minimums. Okay? This graph does not have an absolute maximum. Want to guess why? It goes up forever. So there is no absolute maximum. All right? An absolute maximum would be the highest y-valued coordinate that a graph has. Okay? And in this particular graph, it does not have an absolute maximum because it goes up forever. Okay?
Wait, what is the highest?
Absolute maximum would be the highest y-value that a graph has. The furthest up point on a graph. This one doesn't have one because if you think you can name the highest point on the graph, I can name one higher. Okay, and we can just keep going back and forth because numbers never stop, right? Okay? Now, this graph does have an absolute minimum. Right there. This is definitely the lowest y-value on the entire graph. So this would be our absolute minimum, whatever that coordinate is. I'll find it here in just a second. You guys will be using Desmos a lot. So the absolute minimum is negative 0.656, comma, negative 2.248. That is the absolute minimum. Okay? Then there are also things called relative maximums and relative minimums. And let me explain those. A relative extrema, a relative maximum or minimum, is a maximum value if you're only looking in its general vicinity, in its general area. Okay? Or in other words, you're just looking kind of to the left and right of it, and it's bigger than all the other coordinates just to the left and right of it. Okay? So this value right here is actually a relative maximum. Okay? This coordinate right here is a relative maximum because if you look on either side of it, the y values are smaller, right? Why is it not an absolute maximum? definitely not the highest point on the graph, but relatively speaking, in other words, really close to it, all right, it is bigger than the other y values nearby it. So that is called a relative maximum. Guess what this is called?
Relative minimum.
Is a relative minimum. Okay? This is called a relative minimum right there. Yes?
So with the absolute minimum, could that be relative minimum?
And that's where I was going next, absolutely. This coordinate right down here, not only is it an absolute minimum, it is also a relative minimum. It's both. It's the absolute minimum and it's a relative minimum, because by definition, a relative minimum is a value that's smaller than all their values just to the left and right of it. Okay? So this one will qualify as both absolute max and, absolute min and relative min, where this one is just a relative minimum.
On a test, would you want us to do like both of them?
I would depends on the directions. You'd have to follow whatever the directions say. Okay. On the assignment that you're going to be given, I think we're just doing relative minimums and maximums, but I want you to be aware of what an absolute minimum and maximum is. Okay. So relative maximum, there is only one of them. It is right there at 1,3. And a relative minimum, there were two of them. This one, negative 0.656, comma, negative 2.248, as well as this one right here, 1.906, 1.955. Now those are rounded. They are not exact. Okay. The only way you could find the exact values, like in simplest radical form and things like that, is to use calculus. Okay? Calculus will involve you finding out where the graphs change from decreasing to increasing, or in other words, where graphs turn. Okay? That's what calculus and derivatives will help you find. So when you guys eventually get there, you will figure out how to find the actual coordinates of these without having to do it on Desmos. Okay?
That sounds fun.
It's not bad. It's kind of nice. It kind of you can relate it to physics a lot. All right. It's when you stop accelerating and start decelerating. You know, it's when there is no change. You're not increasing speeds, but you're not decreasing. It's the moment in time where you have stopped increasing and before you start decreasing. So it relates to physics, and I think it's kind of interesting if you like physics. Okay. But so that's absolute maximum, absolute minimum, relative maximum, relative minimum. So what I'm going to ask you guys to do is, there are 5 of these, okay? I want you guys to sketch the graphs, okay? I want you to sketch the graphs, approximate each real zero to the nearest tenth, and approximate the minimums and maximums to the nearest tenths. Okay? So all you'll do is use Desmos. You'll get really good at graphing these. Okay? Unfortunately, I don't have physical paper copies for you, so you might want to either draw your own, or you might want to use some of this graph paper, whatever you want to do. But I want you guys to do these 5 problems that are on this document. Okay? You can find this document on Schoology. So make sure you grab some graph paper if you're going to use graph paper. But on Schoology, if you're looking for the document, it is this middle one right here. It is the middle one.